We will work over coordinate geometry today, and that will be your 1.8 notes. First thing you need to understand or you need to remember is your distance formula and midpoint formula. You have done this so many times before. And of course, when it says x2, you understand, and x1, it means that you have 2 points, x1 comma y1, and the point x2 comma y2. And the distance will be the square root of x2 minus x1 squared plus y2 minus y1 squared. For the midpoint formula, you will be just adding the two x's divided by 2 and add the two y's divided by 2. Problems are not always as simple as finding the distance of the midpoints. Let's look at the first one. It says find a point on the x-axis that is equidistant from the point 2, 2, and 3, negative 1. Well, in order for you to find this point, I will just do a little sketch here. The first point is the point 2, 2. So if I want to plot that point, imagine this is 2 and this is 2. It will be a point here. The second one is 3, negative 1. 3, negative 1. It will be a point here. Since we're looking for a point that is on the x-axis, let's say I decide to graph this line from here to here. We're looking for the intersection between this line and the x-axis. One thing I know is that the point that is on the x-axis, which is, I will mark it red, which is this point, we have the coordinates x, comma, on the x-axis will be x, on the y-axis would be 0. So if it has this coordinate and is equidistant, it means that this distance here is the same thing as this distance. So I will use the distance formula with this point between 2 and x comma 0. So the first distance formula would be the square root of x minus 2 square plus 0 minus 2 square. Again, I'm doing 0 minus 2. Maybe you want me to write it as 0 minus 2 so that you know why it's just end up being just negative 2 squared. This distance apparently is the same thing as the distance from x0 till 3 negative 1 plus 0 minus negative 1 square. Well, I would go ahead and simplify this one and I will square both sides. I will end up with x minus 2 square plus 4 is apparently equal to x minus 3 square plus 1. If I expand the left side, I will have x squared minus 4x plus 4 plus an additional 4 is equal to x squared minus 6x plus 9 plus 1. Well, if you rearrange this one, you will first notice that the x squared will go away. So this x squared and this x squared will go away. I will end up with negative 4x here and negative 6x. So I have negative 4x plus, I put 8 minus 4x is apparently equal to, and on this side, I have negative 6x plus 10. But I will move all the x's to the left side. If I move everything to the left side, I will end up with 2x is equal to, and I move the 8 to the right side, it will be equal to 2. So I have x equals 1. Now that I have the value of 1, the point that we were looking for is the point 1 comma 0. Alright, let's talk about ellipses. If I have an ellipse and I'm looking for an x and y intercept, first of all, the x-intercept, to be called x-intercept, it has the coordinates of x comma 0. Compared to the y-intercept, the y-intercept always have coordinates 0 comma y. In other words, to find your x-intercept, plug in 0 for y. To find your y-intercept, plug in 0 for x. So I will call this one x-intercept, and this is of course your y-intercept. Let's go ahead and look for the x and y intercept of this ellipse. Starting with the x-intercept. X-intercept means X-intercept means plug in y equals 0. So if y is equal to 0, I will end up with x squared over 9 plus this whole thing will be 0. So I just need x squared over 9 plus 0 over 4 equals 1. In other words, I have x squared over 9 is equal to 1, or x squared equals 9. The possible values of x are plus or minus 3. So the two coordinates possible are the following. The first one will be the coordinates negative 3, comma 0. The other one will be 3, comma 0. This will be your x-intercept. Now I will do the y-intercept as well. For the y-intercept, all I have to do is plug in x is equal to 0. If I do the same thing I did on the previous one, I will have 0 over 9, 0 squared over 9, plus this time y squared over 4 is equal to 1. Well, this whole portion on the left side we cancel because that's just 0. And if you cross multiply, you end up with y squared is equal to 4. So y is equal to plus or minus 2. So the two coordinates are 0, comma negative 2 and 0, comma 2. Once again, these here are your x-intercept, and these on the other hand are the y-intercept. All right, let's talk about circle. Before we talk about circle, I need to refresh your memory. The standard equation of a circle is x minus h squared plus y minus k squared equals r squared. Of course, the standard is hk, and the radius is r. Now, here it says find the equation of a circle with radius 3 and center at 2, 5. Note that when the value move from center to the standard equation, you see there's a switch of sign. So here I will have x minus 2 squared plus y minus 5 squared is equal to the radius squared, which is 3 squared, actually 9. Sometimes it will not be given, like example, the problem number 4. Find the center and radius of the circle. What I will do first is to group them. I will have x squared plus 2x, I group my x's, plus y squared minus 6y, I group my y's, and I can set it equal to the number negative 7. From here, I will complete the square root twice. Let's start with completing the square with the x's. This is actually x plus 1, the whole thing squared. And if you remember how completing the square is, you need to add the square of this value on the opposite side. So I have negative 7, and I must add a 1 here. Let's do the same thing for the y. These two, it will be y. I divide this by 2, meaning minus 3, the whole thing squared. And what I will add here is the square of negative 3, which is 9. There's still a plus in between. So this is x plus 1 squared plus y minus 3 squared is equal to 9 plus 1 is 10 minus 7 will be 3. So the center is at negative 1 comma 3, and the radius is square root of 3. Let's continue with our coordinate geometry. Let's talk about symmetries. We can have symmetry with respect to the x-axis, the y-axis, or the origin. When two values are symmetry with respect to the x-axis, imagine I have this point. The symmetry of this point, I'm giving some value 1, 2. The symmetry of this point with respect to the x-axis will be the point down here, and the coordinate of the point down here will be, starting with the green one, the point down here will be negative 1, 2. Note that the only thing actually is 1, negative 2. The only thing that will change is the y value. That's why I say when it's the x symmetry with respect to the x, the y is the only one that changed. So you can write this statement here. You replace for x-axis, you replace y with negative y. If equation is unchanged, graph is symmetry that respects to the x-axis. I'm gonna come back to this sentence in a minute. I know you just got upset because I erased it, but you'll be all right. Let's do now that respect to the y-axis. To the y-axis, if I find the symmetry of this that respect to the y-axis, I will end up with a point here. Coordinates will be -1, 2. In other words, the only thing that changed is the x value. It got a negative compared to this one where it was just the y value. That respect to the origin now, it means that I'm translating this across the origin, and it will give me a point here. The coordinate of this point will be now -1, -2. In other words, both of them will change the sign. Now, if I just give you an equation to know if a symmetry that respect to the x, y, or z, you first replace y with -y. That's what I said earlier. If the equation is unchanged, then the graph is symmetry that respect to the x-axis. You also replace now, if not, you replace now x with -x. This remains the same. That will be for the y-axis. And if you replace x by -x and y by -y, and the equation, the graphs remain unchanged, then that's over the origin. I will do one simple example with y'all. Let's start with an equation such as, here's my equation. Y is equal to x cubed minus 9x. Let's start by checking for symmetry that respect to the x-axis. So I have a here. I can replace y. I'm checking x-axis. I will replace y by -y. So I will say -y is equal to x cubed minus 9x. Now, let me go ahead and remove this -y. Multiply everything by negative to get y is equal to -x cubed plus 9x. Obviously, we get a different equation, so I can conclude and say not the same. So it's not symmetry that respect to the x-axis. Let's do now the y-axis. For the y-axis, as I mentioned before, you're replacing x by -x. In other words, here I will have y is equal to -x cubed minus 9 times -x. If I simplify this, I get -x cubed plus 9. Well, once again, this is not the same. And because it's not the same, it's not symmetry that respect to the y-axis. Let's check for origin. For the origin, you replace everything. So y is replaced by, for the origin, you replace y by -y and x by -x. Let's see if we get the same thing. Well, I will have, multiply everything by negative, you end up with y. Let's start by simplifying the right side. -x cubed plus 9x. Now let's multiply everything by negative to get y is equal to x cubed minus 9x. Well, this time we have the same. So this equation, we have a symmetry with respect to the origin.